about properties of exponents, right? I think this is an easier unit than what we've done. Piecewise, unit 1 is the worst. Piecewise is next worst, and now we're kind of. You'll be glad you didn't. All right, so we are going to talk about struggling. We love math because we love math. Tell me what a polynomial is. You're close. Many. So poly is many. You're actually really close. It's many terms, but it can actually be, it doesn't have to be many. It's just, it could be one or more terms based on polynomial. So now my question to you is, what is a term? Okay, I hear it could be a constant. It could have a variable. What else? It could have a number variable. All the letters. So this is a term. This is a term. You said it could be a constant. That's a term. Can anything else? Is it x squared? Okay, so what did you add to it there? A what? The squared, which is an exponent. So it can be comprised of constants, but I'm going to call them, instead of constants, I'm going to call them coefficients. But a constant is also a term as well. You can have a constant as a term. But coefficients, variables, exponents all put together make a term, okay? So there's no addition or subtraction in terms. There's only multiplication. No plus or minus, only, get out of there. Only multiply. So x, y, and 3, these are all terms. Give me another term that involves an exponent. X squared. Give me one that involves a coefficient and a 2x squared. These are all terms. Do we agree? Now, so a polynomial is more than one or more terms. But here's the thing with a polynomial. So I'm one or more terms that are added or subtracted together. And I can't have no negative exponent. For a polynomial, you can terms, if I had like x squared plus 3x, this altogether is not a term, but this is a term and this is a term. So there are two terms. The terms themselves you don't add or subtract, but within the polynomial they're added or subtracted. Also know irrational exponents. What's an irrational number? Close. It could be. Say it again. Number that you can't put into a fraction. That's exactly right. It's a decimal that goes on forever with no pattern. It doesn't terminate. It doesn't repeat. It just keeps going. Give me an example. Yeah. Pi is a great example of an irrational number. There is no pattern. I can't write it as a fraction. It goes on forever. There's no pattern to the numbers. They never start repeating. Give me another example of an irrational number. If it's repeating, then it won't work. Boom, you just stopped, so it's not irrational. You made it into a fraction, so it's not irrational. Square root of 3. Square root of 3 is an irrational number. No. No. But it's... We will work mainly, yeah. there's no adding or subtracting within a term, only multiplying, but there is adding or you can add or subtract the terms. So this is a polynomial because I've added or subtracted, and it's made up of two terms, not just one term, because of the plus in there. Right. Under polynomials, we classify them based on their number of terms and their degree, and we're going to talk about both of those. The number of terms gives me a specific name. This is a little chart you'll want to put in your notes somewhere. If I have one term, it is called monomial. That's exactly right. Mono means one. Monomial. How about two terms? Binomial. How about three? Look at y'all. How about four? Greater than 4 or bigger, I just call it a polynomial. Now, they are all polynomials. A monomial is a polynomial. A binomial is a it's just a more specific name for it. Does that make sense? Now, when we start writing polynomials, we write them in what we call standard form. Do y'all have that? What does standard form of a quadratic look like? Quadratic means what? Ax squared plus bx plus c. Now, what do you notice? If this is standard form, tell me what you notice about the exponents. Okay, somebody said there's 2. What's the exponent on this one? 1. I could technically put an x with a what exponent here? A 0. What do you notice about the exponents? Descending. They start with the biggest and they go down. So that's true. That's true of any polynomial. Standard form means you start with the biggest exponent. Does anyone know what the biggest exponent of a polynomial is called? That's the coefficient. Somebody in here knows this. Does anybody know it before I give you a hint? Starts with a D.
Decimal.
Degree. The biggest exponent in a polynomial is also known as the degree of that polynomial. So every quadratic has a degree of what? 2, because that's the biggest exponent. Every linear function has a degree of 1. Every constant has a degree of 0. Okay, so we start. Go ahead. No, that's okay. Yes. Yes. So what we'll have to do is we will rework these equations or these expressions to standard form so that they start with the biggest exponent and they work their way down to the smallest, okay? So start with the biggest exponent to the smallest. We're going to talk about the biggest exponent. Depends on what you're looking at. I'm also going to put here in parentheses because sometimes you'll see this come up every now and then. We don't use it much past here, which is why I don't harp on it a lot, but you may see it on SAT and ACT if you're coming up. There may be some mixed variables in there. It's always also alphabetical order if you're looking at which one. If you've got like an A and a B, the A would come before the B. Most of ours are just going to be X's though. All right, so let me show you one. Oh my gosh. My first question to you is this a polynomial? What can't be negative? It is a polynomial. It might not be in standard form, but how is it a polynomial? Okay, go back and read it. What cannot be irrational? It has no negative exponents, and the exponents are not irrational. I didn't specify on coefficients, right? That was a trick question. I tried to trick you on that one. But because all I'm looking at are exponents, 3, 2, this would have a 0 exponent, and 5, tells me that yes, this is indeed a polynomial. How many terms do you see in this polynomial? 4 terms. Write this in standard form. Fine. It's the biggest exponent. What needs to come next? And next? What is the degree of this polynomial? 5. What is the leading coefficient of this degree? What is a leading coefficient, by the way? When it's in standard form, it leads the equation. Leads equation. This is important though. When in standard. So, degree, leading coefficient. I haven't even started teaching this stuff yet. Leading coefficient will be 6, yes. What is this called? N number. Besides the N number. Okay, it would be yes, it's the constant. It would be the y-intercept if I were graphing, but not necessarily graphing. All right, so I told you we classified based on the number of terms. We got monomial, binomial, trinomial, polynomial. We also classify based on degree. So my polynomials have 2 parts to their name. Just like you have a first name and a last name, they have 2 parts to their names. They're classified by their number of terms, 1, and they're also classified by their degree. Now, if I have a degree of 0, what would that look like as a, no, think about it. Okay, yes, it's to the, that means x is to the, that means it's 1, but there could be something else. But what is that called? What kind of equation would that be? Oh, you're close. Close. It's a special kind of linear, though. This is just a horizontal line. If you think about, go back to your polynomial. What did we say that term was called? A constant. So if it's got a degree of 0, it's just constant. Graphed, you're right though, graphed, it looks like a line, but it's a horizontal line. Makes it 1 so that, right, exactly. But what if I had a degree of 1? What if my biggest exponent was 1? Then it's linear. That's exactly right. So that's when I can do this or this. Looks very similar to like your slope-intercept form of a line. Okay, how about a degree? Y'all should all know this one. Quadratic. Past that, you may not know. Oh my goodness. How about a degree of 3? What? Oh my goodness. No. Anybody? When I raise something to, when I raise something to the second power, I say I've squared it. Cubic. It's a cubic. How about to the fourth power? What'd you say? You would think, right? This is where students get mixed up all the time. It's actually called a quartic. Quartic. You're actually right. I am. Yes. Past 5. Yep. Past 5, we don't really call them a name. We just say, for 6 plus, we say nth degree, and we put whatever this number is in for the n. We say whatever degree polynomial. So if you work on that and let us know. Take us up through 20. Okay. So if I had a degree of 8, I would just call that an 8th degree polynomial. Shut up. Oh, come on. Five must be my number today.
Fourth guy going front. Then 3. 4s and 3s and 1s and 9.
All right, so give me the polynomial. 2x to the 4th. Classify the polynomial by its degree and number of terms.
What's it?
It's a quartic polynomial. Yep.
Definitely won't enter standby 54 seconds.
Oh no.
Quartic polynomial.
We got today is all about adding, subtracting, and multiplying polynomials. Huh? Yeah. So what's the leading coefficient here? 2, it only leads the equation when you are in standard form, so be very careful. Grayson, take that hat off. What is the degree? 4. What's the constant? -7. All right. Let's talk about how we're going to use this.
Oh, really? Five.
All right. When we add or subtract, I definitely have peripheral vision and can see it shining. Yes. Whenever I'm looking here, I can literally see the board out of the corner of my eye. It's not off. All right.
Ah, you look. Ah, I got it. Guess what I can see right now with my personal vision?
What?
That's not with my personal vision. That's with my straight vision. Next to me, though. I can't see that. But I can see like
If you need to add or subtract polynomials, I am not going to spend a long time on this one example unless somebody needs me to do more, because this is so easy. That's all I'm doing with this. I'm combining like terms. And in fact, I'm going to even change this to if this was subtraction instead. Huh? Add, subtract, multiply, and divide. Yeah, you want to keep this addition? Okay. All right, so first of all, what kind of polynomial do I have first? Name it. A cubic trinomial. A cubic trinomial added to a quadratic trinomial. Does everybody see that? I've got a cubic trinomial adding to a quadratic trinomial. So this is based on the degree, and this is based on how many terms. Both of them have 3 terms, so they're both trinomials, but the degree is different on them. All right, so all I'm going to do is combine like terms. Start with the biggest. There's not one to add it to, right? So it's just 2x cubed. That's right. I only have 1 squared, and I could really just drop these parentheses at this point and combine like terms. And then, that's right, then I've got 3x plus negative 8x minus 5x. That's right. And then minus 1. Yes, Will, say it again. It ends up being a cubic polynomial. How many terms are there? 4. Yes. Leading coefficient, that's right. Huh? Cubic is, it's based on the biggest exponent. Yeah.
Come on, bro, do the dance.
All right. Will, give me a polynomial. A random, make it up. Give me a. Huh? What? All right, nope, you said it. We all heard it. All right, give me, Bella, give me a polynomial. Any polynomial in the whole wide world.
Do it like,
plus 4x to the third minus 7x plus 7.
All right. Okay.
We need to know the hard ones now.
Right. That's right. Good job, Bella. Good job. All right, this is subtraction. So here's what I got to keep in mind. I'm subtracting everything inside that second parentheses, not just the first term. So if you learn subtraction in whatever grade you learned subtraction, and you did same, change, if you're a same, y'all didn't learn subtraction that way? If you did, and you're a keep, change, or same, change, flip, whatever it is you do, then whenever you do your second change, same, change, you have to change everything in the parentheses that follows it. So if that's what you do, you have to do that. You just subtract them. That's what I do. I just subtract them. So here's what I do. I start with, whenever they're not in, I don't always even put them in standard form before I start. I'm going to put my answer in standard form in the end. In other words, I kind of scan it and I say, okay, what's my biggest exponent I have anywhere? It's 4. I circle that one and I say, this is where I'm going to start. Do I have any other powers of 4? Nope. So I've just got 4x to the 4th. I'm done with that. Why is it negative? That's in the same parentheses, the first parentheses. We're just going to, that's fine. We'll just, yeah. All right, so now how about powers of 3? There's 1 over here, but it's negative. That's exactly right, because I'm subtracting all of this. So minus 4x cubed. Yes. All right, how about powers of 2? 2x squared minus 7x squared leaves me with all right, if I asked you what is 2x squared minus 7x squared, what would you tell me?
they're not square.
Yeah, that's not squared though.
What?
Like it's just negative 7x. It's just negative 7x.
There's 2.
Well, do a combination of 7.
Yeah,
We're not doing the same.
Okay, go in order. Everybody with me? We all on the same page now? All right. All right, I'm going to cross these out now because I've used them. Now I've got negative 5x minus negative 7x plus 2x. And then 10 minus 7, 3. Classify the polynomial. Quartic polynomial. Leading coefficient? Constant? Degree. Everybody okay? Let's multiply. Yes. No, we're going to multiply today. Y'all were supposed to have a quiz today on exponents, since we spent 2 days on it.
why can't we just do it?
We're not going to do it today. We're not going to do it today. All right, let's multiply. The reason I kind of run through all this fast is because we've already done this whenever we multiplied binomials together. Oh.
That's how
Give me a polynomial, Grayson. Give me a trinomial.
Two x. Wait, does this number have to be just a plain number? Okay.
Plus.
Minus 1x 4.
What did it do to confidence?
It's okay. Yeah. It's hard.
Alright, 2x1. Alright, plus 1. Minus 3x3.
Now, if I need to multiply these, add what x? Yes, you're right. When we multiply, we're gonna add exponents. But the method in which we're gonna multiply these is the same method that I FOIL in. I don't FOIL, I just distribute, and this is why I just distribute. Because if you just distribute, you can multiply any two polynomials in the whole wide world. I start with the first term and the first polynomial, and here's the only thing that I will tell you as you do this. Never multiply more than 2 at a time. So if you've got 3 polynomials, you'll need to multiply the 2, simplify it, and then multiply it to the third. Like if I had x plus 1 times x minus 3 times 2x plus 7, I couldn't do this. Like I would have to do just 2 of them first, get an answer, and then multiply that to this one. You can't multiply more than 2 together at one time, is what I'm getting at. All right. No, that's not what we're doing here, but I wanted to make sure you had that in your notes if you go back and look at your notes to how do I multiply them. All right. Also, remember, somebody already said it, when you multiply terms, I multiply the coefficients. That's right. And add the exponent. I say that, and you're like, I'm sure you're like, I know that already, but it starts getting confusing with when we start interchanging operations here. All right. What's that for? Oh my goodness. All right, I'm going to start with the first term. Circle it. That first term has to touch every single term in the second parentheses. Okay? It's got to distribute to everything. So here we go. Blame Grayson. He's the one that came up with this too. 6x to the 6th. Is it really hard? No. Yeah, it just takes a long time. All right, now to the next one. Now you're done with that term. It has gone to every single one. So now I got to do the second. Yeah, it's a positive. All right, so plus if you throw craisins in my room, you're going to come after school and clean up craisins from my room. Plus 2x to the third. I'm done with that one. Woo! Last one. Well, when you sit down to do your homework tonight. All right, last one. Whoa, slow down, speed racer. What's negative x to the fourth times negative 3x cubed? Combine your like terms. Start with your biggest exponent.
We shouldn't even call these like, we should call these mega like.
Combine your mega like terms. What's 0? Start with your biggest exponent. I always start with my biggest. I always circle as I go on these, and I mark out as I go. It helps me. Even now, I still do this to try to keep up with my work. Negative 9x to the 8th. Once I locate the biggest exponent, then I go down from there and I go, okay, do I have any exponents of 7? Yes, I'm looking through. I only have this one. It's plus 3x to the 7. That's right. I've got 6x to the 6 and negative. That's nice. Those cancel. Good job. You did. Powers of 5. Now, listen, I have my Algebra 1 kids draw different shapes around the different like terms. So, 4 plus 2 would be 8. Yeah. You'd add those coefficients. Oh. Did I say that? 6. 3x to the 5th minus 2x to the 5th plus x to the 5th. Yes. Powers of 4, that's exactly right. I got 4x to the 4th minus x to the 4th. Did I mess up? I don't know. All right, somebody said it. It's an 8th degree polynomial. Division, we're only going to do division by a monomial today. I'm not going to do bigger. Well, it's actually, no, you won't.
Is the constant 0?
Yes.
You know what we have to do after you survive?
What is the
Oh, that's tough.
and the
You just did exactly.
and the degree
The leading coefficient is negative 9. Degrees 8. All right. Shh, 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 shh. Almost done. Stay with me. This is probably the easiest.
Are there going to be questions that are homework that are following anyone that are further?
No. Now, on your homework, because this, listen, guys, this was a question. I don't want to take up any more class time to do this, but like one of the ones on your homework is this. But remember, you can't do more than 2 at a time. So you got to do 2. Take any 2 that you want and multiply them, right? Right? And these other 2 are still here. So now I do these 2 together. I get that answer. And I have to multiply it to the a plus 8. 8. Okay. All right. Also, along these lines, you have one that looks like this. Can I distribute that 3? I hear yes and no. No, because there's a plus in there. Remember those exponent properties, and we did that foldable, and we said only if you're multiplying or dividing can you distribute the exponents. If you are adding or subtracting, you cannot. So you would have to do I'm waiting on the moans and the groans as I write that. All right. I'm trying to get done in time enough where you can do your homework. Dividing by a monomial. And then I'm done, I promise. The premise of this, I feel like I just teach to you, Grayson, because I can't quit watching you because you misbehave so much. Do you agree? Do you agree that you could split this up this way? Yes. Whenever you are adding or subtracting in the numerator, you can always split up with that common denominator, okay? I know. Were you? All right. So here's what we're going to do, and I'm going to do one off of your homework with you. How does it go? Listen, I'm going to pass this around. It's 2 pages, but you'll see why it's 2 pages in just a second. There's some little notes at the top. I want you to take one of each of them, okay? Does everybody hear me? Yes. One of each. Here's the first one going around at the top page. All right. Let me show you about dividing by a monomial. Why not? Yes. Oh yeah, no. I think the easiest way to teach this is to do an example. Yeah. Dividing is very easy on this because we're technically doing it. So look, we're going to use those properties of exponents we did. When I divide, this is only when we divide by a monomial. What's a monomial? One term, right? This is a monomial. If I divide by a monomial, what am I heading to? Yeah, I probably wouldn't use the other stapler wherever it is. We're going to split it into separate fractions. And then we're going to simplify each fraction. I know, it's a lot. I know, I'm sorry. Oh, Bella's got the regular stapler. She'll pass it around. We'll pass it around. No, she's waiting on her pages. All right. I can recognize that this is being divided by a monomial, right? Say right, because that's right. So I'm going to split it into two separate fractions. 40m cubed n4 over 8m squared n5 minus 24m2 n7 over 8m2 n5. All right, simplify each one. Look at the coefficients in front. 40 and 8. 5.
5m over m.
Look at, yes, ma'am. I missed a little bit. Minus. Close. What happens to the M's?
Do the
They
dance.
cancel out. They
Do the
cancel out.
dance. Do the dance. Do the dance. Do the dance. No,
Yes.
you have